Hey everyone, and welcome to this explainer. If you've ever watched a young learner really struggle to grasp abstract math concepts, you know exactly how tough it is to make those foundational ideas truly stick. Well, today, we're exploring some fascinating source materials that propose a massive shift in early math education. We're talking about taking arithmetic completely out of the standard, boring textbook and dropping it directly into immersive play. We're going to look at this transition from pure theory to interactive practice and uncover why it is just so incredibly effective. So, let's dive right into the core question. How on earth do we make big numbers fun and actually comprehensible for little learners? I mean, it's one thing to teach a kid to count to 10 on their fingers, right? But moving beyond rote memorization to effectively teach abstract, larger numbers, that's a massive cognitive leap. Think about it. To a 5 or 6-year-old, a number like 50 or 75 isn't an intuitive quantity. It's really just a sound they've memorized. The source materials we're unpacking today actually offer a pedagogical solution to bridge that exact gap between memorizing a sound and genuinely understanding a quantity. All right, let's start with part 1, the foundations of primary math, those essential building blocks for young learners.
Before we get to the fun stuff, we need to map out the actual foundational skills being taught. The educational materials outline 4 core concepts that basically establish a solid comprehension of basic arithmetic. First up, addition, which is taught by combining various groups to get a total. Second is the ability to confidently count all the way up to 100. Third is place value, so teaching kids how to construct numbers using tens and ones. And finally, subtraction, which is illustrated as finding the remaining quantity after items are actively taken away. And what's absolutely crucial here is how interconnected these pillars are. Like, a child literally cannot consistently perform double-digit subtraction without a rock-solid grasp of place value. These are the absolute non-negotiables of early math. Now, this comparison highlights the core conflict in teaching those foundational blocks: abstract numbers versus concrete visuals. The source materials dive deep into the cognitive friction that happens when we just ask kids to memorize isolated digits and arbitrary rules. It rarely clicks. Why? Because the brain has no tangible anchor for that information. But conversely, shifting toward concrete visuals, like actually combining physical groups and items, well, that massively reduces the cognitive load. It leverages a kid's natural intuition for the physical world, creating this accessible, hands-on learning experience that makes mathematical symbols finally mean something real. Moving right along to section 2, the power of play and making math interactive. Okay, so how do we actually deliver those concrete visuals effectively? Well, the sources detail the use of highly engaging video presentations perfectly paired with interactive scenarios. Take Professor Pixel's Play Restaurant, for example. Imagine this incredibly animated setting where children step right into a virtual restaurant. The voiceover in the material literally tells the learner, "Today, you're the head chef and server." And boom, this introduces a super powerful concept: agency. By giving the learner an active role, the math instantly transforms from, some arbitrary task assigned by a teacher into an essential tool. They literally need this math tool to achieve a goal in their new world, running a busy kitchen. Let's look at how this plays out in section 3, the chef's challenge, where we start using math for bigger numbers. So picture this targeted problem-based scenario. It's specifically designed to tackle addition and subtraction for numbers up to 100. Just consider how this is framed for the learner. A customer walks in and orders 25 chicken nuggets and 12 fries, and you, the chef, need to know exactly how many items to prepare in total. Instead of staring at a vertical math equation on some sterile whiteboard, the child is faced with a tangible catering emergency. They have to solve this practical dilemma to keep the game moving, and they naturally start applying concepts like tens and ones to combine those massive orders. And when the student arrives at 37, the pedagogical payoff is absolutely immense. In the interactive video, students might physically click on food items to add them to an order, actually watching the numbers update on screen right alongside the visual representation of all that food. Getting that visual feedback of seeing exactly 37 items completely solidifies the abstract concept of two-digit addition. It bridges the gap flawlessly. The kid isn't just processing 2 floating abstract numbers anymore. They are successfully stacking 25 nuggets and 12 fries onto a digital tray. But hey, a realistic restaurant simulation wouldn't be complete without a little bit of chaos, right? Imagine 40 ice creams were ordered, but oh no, 10 of them just melted. How many good ice creams are left?
The source material highlights just how clever it is to use kitchen mishaps as a totally natural, low-stakes way to introduce subtraction. It introduces the friction of having to take something away, but without inducing any of that math anxiety that usually comes with a pop quiz or a boring subtraction worksheet.
And by arriving at 30, that abstract rule of subtraction is firmly cemented in the child's brain through a tangible physical removal. We started with a concrete set of 40 visual items, and then watched as 10 spoiled items physically disappeared from the screen. The source materials heavily emphasize that this physical action of taking something away makes the whole concept highly tangible. The math is no longer just something they have to try and remember, it's an event they literally just experienced.
Which brings us to our final section: solving real-world problems and the overarching impact of roleplay. To truly understand why this immersive play restaurant method works so incredibly well, we really have to look at the behavioral loop it creates. This right here is problem-based learning in action. Step 1, take the order. Step 2, add or subtract items. Step 3, serve the total. The materials emphasize that this sequence isn't just math, it's actually a fantastic executive function exercise. It mimics real adult problem solving. Kids aren't just blindly reacting to isolated prompts, they are walking through a logical sequence of events where mathematical operations are simply the necessary steps to achieve their ultimate fun goal of serving the customer. There's a direct quote from the educational presentation that really hits the nail on the head. This kind of play helps us practice addition and subtraction with two-digit numbers, making it super practical and fun. I want to focus on that phrase right there, super practical, because practicality is literally the antidote to math anxiety. When children are deeply engaged in a state of play, or a state of flow, really, and they clearly see the practical, immediate application of building numbers out of tens and ones, the fear of math just vanishes. They are highly engaged, they're learning intrinsically, and most importantly, they're actually retaining the information. So, I want to leave you with this final provocative thought. If a simple play restaurant scenario can successfully demystify intimidating double-digit arithmetic, how might we completely redesign other scary subjects, like fractions, or even physics, by replacing the traditional textbook with an immersive, interactive world? Just think about the possibilities for the future of education. Anyway, thank you so much for joining me for this explainer as we broke down the transition from mathematical theory to interactive play. Keep learning, keep exploring, and I'll catch you next time.